Alright, so we're on our 5-5 notes, and there's two main points I want to talk about. Let me get my hand off of there. So the two main points that we talked about for 5-5, again, the first one is this idea that the longest side is going to be always opposite the largest angle. So if I look at these three, the angles are 100, 44, 34. So the largest angle, if I go opposite that, opposite the largest angle is the longest side, which kind of makes sense because it has to open up wide and it creates that longest side. Also, the smallest angle is opposite the, there it is, the smallest angle, 28.9, is opposite the smallest side, 8.9. So that's going to hold no matter what. And if I change it, because right now the green is the longest side, if I change it so the green is no longer the longest side, let's make blue the longest side. So now green is not the longest. Blue is the longest, so now blue, the longest side, the opposite angle, 80.4, is the largest angle. Right? So largest angle always opens up opposite to the longest side. Looks like the red is still the smallest. The smallest angle always opens up to the shortest side length. Right? That was the first thing. Okay, so let's write that down. So again, the angle opposite the longest side is the largest angle. And vice versa, the side opposite the largest angle is the longest side. And of course, it also works for the smaller ones. The smallest angle opens up to the smallest side. I guess I could put an arrow both directions. Smallest side opens up to the smallest angle. And the second thing, so the second thing we talked about, is this idea of how to form triangles. So if we take, say we take a triangle like this. Let's say the longest side is 14. If the other two sides are 3 and 7, we can see clearly that that does not form a triangle. It's too short. If I increase the other side to, let's say, 7 and 7, even 7 and 7 doesn't work because it just creates a straight line. They're not going to actually touch here. So the requirement, as we talked about, is that the two sides added up have to be greater than the third side. Right now they're not. If I increase this to 8, now suddenly I can make a triangle, right? So 8, 7, and 14. 8 plus 7 is greater than 14, so we can make a triangle. This has to work for all three sides. So if we change it so that, for example, this B is the longest side, so let's just shrink this down. So B is the longest side. So we can see that, for example, if we have 3 and 3, 3 and 3, and 8, that's not going to work because 3 plus 3 is not bigger than 8. Even if I increase this to 5, it's still not going to be enough. It's not going to reach because 3 plus 5 is only equal to 8. Again, all the other two sides must be greater than the third side, and now we can make a triangle. So 4, 5, and 8. Yeah. So that is the main point. It's not quite making one, but you get the picture. Okay, so let's write that down. So that's the second main point, again, the sum. So if I add up the other two sides, of any two sides of the triangle must be greater than the third side. So those are our two main points on triangle inequalities. So let's try a few problems, and then you'll try some on your own, and I'll put another video up with the answers. You can check those afterwards. So you're constructing a stage prop with a mountain right here, so this is just a triangle. The bottom edge of the mountain is about 27 feet long. So let's go ahead and label the bottom edge 27 feet. The left slope is about 24 feet long. The right is about 20 feet long. You were told that one of the angles is about 46, the other is about 59. Which is the angle measure? What is the angle measure at the peak of the mountain? So if you're having trouble seeing this, you can also redraw the triangle. Out here, that's fine. So let's take a look. So we know 46 and 59, so we know by the triangle angle sum theorem that this has to equal 180 when I add them all together. So if I add 46 and 59, let's see, 40 and 50 makes 90, 9 and 6 makes 15, so that's going to be 105 degrees. So the third angle must be 180 minus 105, right? 180 minus 105. That would be 80 minus 5, or 75 degrees. Okay, so our three angles must be 46 degrees, 59 degrees, and 75 degrees. So how do we know which one goes at the peak? Again, the idea is that the smallest angle goes with the shortest side, and the longest side goes with the biggest angle. So let's just kind of go in order. The smallest side takes the smallest angle, so this 46 degrees would go here, smallest. Then the medium one, 59 degrees, goes with the medium side right here, so 59 right, is opposite this medium side. And then the biggest angle, 75 degrees, is going to go with the longest side right here, so 75 degrees is going to go right there. The biggest angle opens up to the biggest side, so our answer is 75 degrees. 75 degrees is the angle at the peak of the mountain. All right, so we have a different stage prop with a right triangle, so we have 90 degrees. The sides are 6, 8, and 10 feet long. The angles are 90, 37, and 53 degrees. So we have to sketch and label diagram with the shortest side on the bottom, the right angle at the left. So for these sketching problems, you can just try to kind of guess and check. So normally I like to put the 90 degrees at the top. So I like to sketch like this with the box here. But if I do that, remember 90 degrees is the longest angle, right? This is the hypotenuse. And so I don't want this because I want the shortest side on the bottom. So this is not right. So maybe I'll try to put, let's try to put the 37 degrees at the top, right? The shortest one at the top. So 37 degrees would be like a little bit less than half of this because that would be 45. So it maybe kind of look like this, 37 degrees. Okay, so kind of my right angle fell right here. That means 53 right here. So the shortest, let's see, that looks good. The shortest is on the bottom because this is opposite the smallest angle, except it says the right angle is at the left. So I'm still a little bit wrong. I just need to flip this. So let me just redraw it now one more time. 37 degrees at the top, right? That's good because I want the shortest side on the bottom. 90 degrees at the left, and then 53 degrees here. All right, how do I label my sides? 6, 8, and 10. Who takes which? Again, the shortest one goes opposite 37, 6 feet. The medium one goes opposite the medium one, so that's 8 feet. And then the hypotenuse is going to be the longest one, so that's going to be my 10 feet. All right, so that was the first main concept, and we'll come back and practice those. In fact, yeah, why don't we go ahead and just go to the back right now and practice some of these. So, order each side from shortest to longest. Order each side from shortest to longest. So again, we just look at the angles, and we say, all right, shortest first, so that would be opposite this. So it would be TS. And then medium would be opposite the medium angle, so 48 degrees, so US. And then the longest would be opposite the biggest angle, that would be this one right here, UT. Okay. Same thing with this, shortest to longest, so this is my shortest, opposite 50, so VW. Then the medium one, VX. And then the biggest one is opposite 70 degrees, XW. Okay, we can also go in reverse. Order the angles from smallest to largest. So we just go in reverse, so we look, okay, who's the smallest side? That's 10. So that would be this angle right here, angle R would be the smallest. I can just use one letter because it's unambiguous who angle R is. And then the medium angle would be opposite this medium side here, so that would be angle Q. And then the biggest angle would be opposite the longest side, that would be angle S. Okay, same thing here. So smallest would be opposite this one right here, so angle P. Medium would be opposite the 13, so angle R. And then the longest would be opposite the 14, angle Q. So I'll put up the answers. I want you to try, why don't you try 2, 4, 6, and 8, and then the second video will have all of those answers. All right, so let's talk about the second main topic. I'm talking about triangle inequalities, and again, we talked about this longest side, largest angle, but the second main topic is that, again, you have to check to even make a triangle. The triangle inequality theorem says that the sum of any two sides of a triangle must be greater than the third side. So, in other words, again, if you have a triangle, you have these three sides, so this makes a triangle. Yep. 12, 8, and 15. So 12 plus 8 has to be bigger than 15 because, again, if they're not, for example, if it's like 4 and 8, so if these two are less than the third side, it's not going to make a triangle. And even if they are equal to the third side, so let's say we have 7 and 8. 7 and 8 is just going to make this straight line here. So we need to check if each pair of two sides is in fact greater than the third side. It has to pass all three checks, and then we can declare that, yes, this could be a triangle. So let's try one question, kind of simpler first. So can 10, 9, and 2 make a triangle? 10, 9, and 2. So again, we have to actually check, is each pair of two sides bigger than the third side? So just kind of pick each pair. So we could say something like this, 10 plus 9. So these two sides, are they bigger? So like a greater than sign with a question mark. Is 10 plus 9 bigger than the third side too? Right? Obviously 10 and 9, 19 is bigger than 2, so that works. So that passes the first test. But now we have to look at the other sets. So let's take a look at 10 and 2. So is 10 plus 2 greater than the third side? 9. Right? 10 and 2, is that bigger than the third side? 9. So is 12, put a question mark, 12 greater than 9? It is. Right? So that works. We're not quite done. We have to look at the third side. So 9 and 2. So the sum is 9 and 2 combined greater than, question mark, the third side, 10. Well, since this is 11, 11 is bigger than 10, so yes. So it looks like all three check out. So since all three pairs of two sides are greater than the third side, it does make a triangle. We don't have any issues where it doesn't quite reach or it makes just a straight line, so we can say, yes, this can be a triangle. Okay? I'd like you to try number 10 on your own. We'll go over the answer later. All right, but back to the first side for some more examples. So this is going to now go, we talked about this kind of opposite the largest side, longest side is the largest angle. Now let's talk about the second main point, that to make a triangle, the sum of any two sides of the triangle must be greater than the third side. Okay, that's to create the triangle. It's a triangle inequality theorem. So let's take an example. A triangle has one side of length 12 and another of length 8. What could be the possible lengths of the third side? Okay, 12 and 8, what could be the third side? So let me just try and visualize that. So we have 12 and 8. So not every number works, right? So for example, 3 doesn't work because 3 is too small, right? 3 is too small. So we have to make it, again, so that these two numbers, 8 and 5, remember, these two numbers have to be bigger than the third side, so we have to create an inequality. But we haven't actually captured all the numbers that work here because obviously 12, in our example here, 12 is the biggest side. But it might not always be the case that 12 would be the biggest side. For example, perhaps the third side is actually the longest side. So maybe this mystery side turns out to be, I don't know if I can move these, I guess not. But if the mystery side is, for example, 15, so if this one is 12, let's say we have 12 and something else, right? 12 might not be the biggest side. You could have 12, 8, and 15. So we have to kind of picture two different scenarios here. So two different scenarios. So we have 12 and 8. We have to find a mystery side. We'll call it x. So what is the length of this mystery side? Again, we have two possibilities. X could be one of the small sides, or x could be the large side. Okay, so let's create an inequality. So in either case, remember the triangle inequality theorem says that the two small sides added up still have to be greater than the third side. So we say x plus 8 must be greater than 12. Right? So if x is the small side, one of the small sides, this plus this still has to be bigger than 12. Now algebraically we can just solve, subtract 8, and we get x must be greater than 4. It cannot be 4. Right? And you can kind of look at this and that makes sense because if x was 4, you'd have 4 and 8, and again it wouldn't quite make a triangle, it would just kind of come together and make a little line like we saw. Okay, so x could be one of the small sides. On the other hand, the unknown side could be the largest side, in which case we have to make a different inequality. So we'd say that 12 plus 8, so the two small sides, so x is the larger side now, so 12 plus 8 has to still be, again, by the triangle inequality theorem, greater than the third side, in this case, x. We combine that, so 12 plus 8, so 20 must be greater than x. So here's our two constraints. X has to be bigger than 4, and yet 20 has to be bigger than x. Often we write that as x has to be less than 20. So these are the two constraints, and in fact we often write this in one line. So x is bigger than 4 and x is less than 20. We put x in the middle like this, and we say x must be greater than 4 and x must be less than 20. We saw that last year in algebra. So this captures this in a little bit neater way. Okay, so x is between 4 and 20. So we can see that, like, if x was exactly 20, that wouldn't work, because again 12 and 8 would just make a straight line. 21 would not work, it'd be too big. 22 would not work, but anything less than 20, so like 19, this makes a triangle. 18, this works. All the way down, it works, all the way down to 4. And again, 4 doesn't work because this wouldn't make a triangle. 3, and so on and so forth. So anything between 4 and 20, not including 4 and 20, will work. And now let's talk about this last type of problem where we did the demo where we have two sides. And again, the main idea is think about your missing side could either be the short side or it could be the long side. So you have to think of two different ways to write this inequality. We'll just use x to represent our mystery side. So two sides have the following measures, 6 and 12. Find the range of possibilities for the third side. So we'll call the third side x. Okay, so x. And again, x could be either the small side, so let's consider two cases. Right, x could be small. X is small. So if x is one of the small sides, that means who is the biggest side? Right, who is the longest side? That would be 12, right, if x is small. So that means x and 6 are the two little guys. So x and 6 have to be greater than, still, the big side, 12. Right, that's if x is small. The other case is if x is the longest side. So if x is the largest, or the longest side, I guess I should say. So if x was the largest, then this is the big one, and these are the two little ones, 6 and 12. So your inequality is 6 plus 12. So 6 plus 12 has to be bigger than the third side, which is x. Right, these are the two cases, and we just solve it with a tiny bit of algebra. So we subtract 6. So x has to be greater than 6. That's one condition. And on the large end, if we just combine, we get x, or 18 must be greater than x, or read the other way, x is less than 18. And so again, we could write this like x in a row. So from x's perspective, x must be greater than 6, and yet x must be less than 18. So we can think it like 18 doesn't work, 6 doesn't work, 5 doesn't work, 4 doesn't work, 3 doesn't work, 19 doesn't work. Anything in between 6 and 18 will work. So I'd like you to try number 12 on your own as well, and then we'll go over those at the